very much. Morning, everyone. So what I want to do today is hopefully start you off with a very high bar in terms of our vision for the future. One of the challenges we find is, because we talk about this all the time, you will know that there's been so many initiatives over the year that haven't worked. And so you've got to say, well, why is today different? Why are we going to manage to change things? And certainly what we see is, we've been building safe and secure environments for our families and, communities for thousands of years, if not more than 1 million years, according to The Economist recently. And everything that we make, from ships and planes, so even Boeing make planes all over the world, and then a bigger plane flies them to an assembly factory. So buildings are the only thing that we make on location. And I think sometimes we don't unpack why it's so difficult to transform our project process. So I'm going to come on to all of that before I hand. At the very end of this, we will end up with some real nuts and bolts, but first we've got to start really high with some of the work that we're doing. Now, you've obviously just spoken about AI. I think the timeframes will be much faster than you think, actually. But for us, the first thing that we need to do is change the way we make buildings. We've been constructing buildings for thousands of years. We have to change that as engineers. And sorry, I should have confessed at the start, I am an architect, so, but like the fox in the hen house here. So, but anyway, we need to change the way we design our buildings using industrialized construction, but it's not going to be optimizing construction. It's going to be quite different, and that's what Matt and I are going to show you shortly. Because we do not have the skills to construct into the future, we need to resolve productivity in our sector to drive economic benefits. And of course, we've got demographic change. A lot of the skilled craftspeople out there are retiring. There is no one to replace them. So lots of reasons. But, and here's the rub before AI kicks in. The big shift that we're going to see, and you will see over your career, is a shift from projects to programs. We are working with a number of clients, so this is not the future, this is today for us. In fact, with the work that Matt and I are doing, moving to programs is the past. We're doing a program of work for the Environment Agency. The whole goal is what's the minimum that we can do on a project to make this work. So the sort of project that Matt's going to see, we're mobilizing at a kind of program level, multiple projects using the same kits of parts. And then finally, of course, so we are doing lots of foundational stuff on AI today, but we don't think it will really kick in from a transformation point until about 5 years' time. But in 5 years' time, it will be transformative. Today, most of our buildings are designed from here. This knowledge will be transferred to expert systems but I think five years is a long game. That's transformative, because then all of a sudden for us, we have 73,000 brains we can take into a room for a meeting. Not one, 73,000. That's how profound the change is going to be. So our kits of parts approach is really about shifting from briefing for design and construction. Now, a lot of you will have heard of designing for manufacture and assembly, and I'm going to come on to this at the end of the segue. It's not the same thing. It doesn't slip in between design for construction. It's very different. In some countries, we're mobilizing factories, and I'm going to come back to that. We're certainly setting up new supply chains to make the big things that we're designing. But as I say, the key thing for us is we've got to resolve this productivity gap. Manufacturing has had huge productivity benefits from digital, IoT, cloud technologies, and so on. We need to achieve that. And of course, one of the ways is aggregation of projects. So, again, that's your program. Because economics are simple. The more I make something, the cheaper it gets. So that's dead simple. And of course, we've got 7 MMC technologies. If you don't know these, Google them and you'll get them. And there's lots of benefits to industrialized construction. For me, there's no downsides. You think from a safety point of view, and Matt's going to come on to that, I don't see any downsides. Now, one of the key things for us is those technologies, we find our secret sauce, I would say, is that we do not preempt what solution is going to work for a program of projects for a client. We use design to tease it out. So on our data centers, we're doing a lot of the powertrains, for example, using category 1. On data centers and some of the work that Matt's going to show you, we're using category 2. We use a lot of category 5. So right from the from the outset of a project, we're looking to find the right technology. Now, a good example here for a project we're doing with Lang O'Rourke, actually, and Foster's, where we're trying to tease out, well, what is the right solution? Today, we would do on-site, everything on-site. Maybe in the future, everything's off-site. But we're trying to figure out what is the right solution today as we move to new supply chains. But the key thing for us is really around what you'll see, and Matt's going to show you this, so I'm not going to try and steal his thunder too much, is that it's all about getting the smallest number of easily transportable components. So our team understand logistics inside out, craneage and so on. So we've got crane drivers in the room in the concept phase. But again, sorry, Matt, I'm kind of slowly tipping in your toes here. So, and of course, now that we start to think about how we're making buildings using really big things, I've got to think about how they come. Are they coming in internationally? Are they coming in nationally? Are they coming in locally? We're seeing trends like microfactories. You know, World Economic Forum sees that as one of the biggest changes. And then, of course, on some projects like Manchester, we've got a facility on site. So that whole journey of the product to the site becomes really important. And I've got a project in Toronto just now. We've got a meeting with a client this afternoon. That's one of the first big things. We're saying, well, how do we get the things to site? How do we crane them in? Are we going to use a helicopter? Are we going to use a train to bring them in? So all these sort of conversations. And of course, for me, the big shift that we need to make as professionals is we think like contractors just now. We think like construction. We're all going to have to change our mindset to that of a manufacturer. And trust me, it's very different. Quite happy to discuss that in the break, but it's a very different mindset to think like a manufacturer and how to use robots. But the whole industry needs to change. But there's some amazing opportunities. Like I say, it's much safer doing things in the factory. And the big thing for me is as we start to look at things, so this is Wright's model, which you can Google. I don't have time today to dwell on this story, but the whole point is we're not even at the top of this curve. So this is Wright's model as Henry Ford made more and more Model T Fords. The price got cheaper and cheaper. Same model applied to Tesla. We're not even here. So if we can get our industry onto this curve of aggregation and making things in the factory, we will get our price point of our buildings down below current prices. And this is one that really excites me. Think about it. London has £35 billion of construction output a year. If you take a third of that outside London, imagine what that would be like in the tube in the morning. You've got a third less construction workers. All the accommodation that they stay in is freed up. But more importantly, we're shifting all that effort into the factories. We can drive social value. People can cycle to work every day. We're doing some work on High Speed 2 just now. And this thought of taking workers 20, 30 miles to a really remote site to just put some cables together, it's bonkers. We want to do them in a factory where they can work close to their community. So we see this shift driving massive change and social value propositions as we move from construction to manufacturing at scale. And as I say, maybe lots more microfactories. So I want to quickly hand over to Matt, but finally, so this is what we do today. We design for construction. We subset small parts to the factory. We do one-off shop drawings every time. It's not the future for sure. But the future really is about once we create this content. So what we're now moving to is once we work in a program, Project 1, I now have my fabrication-ready content, and I just use it. So I can now seamlessly in Project 2 use configurators. We can move through the design process super fast. I already have my shop drawings. And some of our other projects that we're doing that have occurred after Manchester, we're designing them in weeks now, and they're taking like 15 days to be put up on site. So that is the future. And the real part of this future is really around that shift from projects to programs. And of course, that shift to design to manufacturing, which is very different. So we're subsetting construction, thinking like manufacturers, procurement at program level, so we can now automate all the way through. And of course, we've got lots of tools that we're developing to drive that digital process. And we have been doing this for 4 years. So this was a proof of concept we developed for Mace 4 years ago for an aviation pier. And really, I think it was game-changing for us because within weeks of doing a design using our technologies, we can do a full bill of materials. So that's the kind of direction of travel. And the structural frame here of course it has to be calculated, but it's calculated from a kit of parts. So we have the beam that we're going to use is already in our catalogue. We're not designing a 500mm deep beam, then going to the fabricator. We're using the fabricator's information, doing our calculations, and then doing the bill of materials. So that's some of the concept, and let's say trying to keep it high level, but certainly we see the future for you. I'm so excited for your generation, actually. It's going to be amazing, shifting away from construction into manufacturing. And Matt's now actually going to show you that it's not just theory, that it's actually been taken right down to the nuts and bolts level. Thank you.
Thanks everyone. Thank you for having me. So I'm going to talk about Manchester Airport Pier 2. Manchester is the third largest airport in the UK. Just a few fun facts. It was originally an RAF base. It started life in 1938, and from there it's developed and expanded to what it is today. Like I say, third largest airport in the UK, 30 million passengers going through there per year at the moment, and that's increasing. Intercontinental air services as well. So this is the project that we're going to talk about here. We're not talking about the entire airport. We're talking about a small section of a project to rebuild Pier 2. And the kit of parts that were the kit of parts element to that project, which WSP delivered, was the nodes and the fixed link bridges which link the pier to the aeroplanes via sky bridges. So you can see on the slide here, there's repetition, which is key for kit of parts for the viability. There's repetition on this project, but there's also, if I just flick back, this infrastructure is common to other airports as well. So there's a potential benefit for MAG, the owners of Manchester, who also own Stansted and East Midlands, and also other airport operators to use the similar approach. So we're going to talk about the delivery of the kit of parts today and some of the practical issues around that. And I'm going to focus on the nodes rather than the fixed link bridges, just because of time pressures. So talking about going back to buildability and just asking yourselves, so what are the benefits that buildability brings? And I'm going to try and give a balanced argument here. There are no downsides to this stuff, but there are challenges, and it's going to change the way we work and the skills we need to have as structural engineers and the conversations we have during project delivery. So a smaller number of components coming to site, but those components are inevitably larger. We've got smaller site teams. Again, just to reflect on that, because you could see that negatively and say, well, that's fewer jobs in the communities, but construction, the kind of statistics for construction in terms of health and well-being and mental health are pretty dire, and that's the subject for another debate probably, but it's a lot healthier for people generally. For us, for me certainly, working in an office is pretty straightforward, but for the majority of the people who work in UK construction industry, it's a pretty nomadic, uncertain life that they lead from project to project, staying away from home for long periods. So definitely big benefits from moving that workforce into more permanent locations. Less change during the construction stage, which is a real problem for productivity and budget control and overrun program management. Improved quality as well. Again, these are all things that have been talked about throughout my career, starting with the Egan report, which was what led to NEC contracts. It was all built around these things. Less weather risk and potential disruption because you're doing things in controlled environmental conditions. You're standardising the build process, so you're getting progressive improvements through repetition. There's less interfaces. The interfaces get resolved in a different way once you've got that manufacturing mindset embedded. And so when you're on site, you're not interfacing between different designs which have been designed by different people and relying on the coordination that occurred during that process. And it's a cleaner, safer, tidier work environment. I think talk about the challenges briefly, you do have to accept when you get involved in this stuff, there's higher consequences of errors generally, is what I would say, because you're making bigger stuff. If it's wrong, it's a big problem. It can be a big problem. You're handling large elements, which logistically is challenging. Transporting and lifting large elements is obviously going to be a little bit more complicated. Knowledge and experience, that's why we're here. You know, the reality is that manufacturing mindset and that knowledge of kitted parts and the expertise in handling large components is not something that we've got a huge amount of knowledge within the construction industry. We need to consider how we address that. Supply chain capacity, another key issue. Talked about transportation and sort of getting a bit more technical. Load paths. Think about structural load paths in a design. Traditional construction is pretty straightforward in the sense that the structure, you build the structure kind of aligned with the load path, slightly in reverse. The foundations go in, blah blah blah. You have to recognise with kitted parts, the load paths are very dynamic, so they're moving around all the time during the manufacturing process, during the assembly process on site. You know, reverse stress can mean all sorts of different things in kitted parts, and you have to be aware and alert to that. So, response to challenges, again, just some key takeaway points. Digital rehearsals, mock-ups and prototypes. You can when you're building stuff, when you're designing stuff for production at scale, you can potentially spend more time and effort and invest more in prototypes and mock-ups. Supply chain engagement, really important. Make sure that the supply chain is capable of delivering what you're designing. Share experience, ask questions, and just don't talk to other people. And it might not be other people in the construction industry. Build knowledge and competence in that. So we've got to invest as an industry in that knowledge. Where do we gain it from? Do we talk to the shipping industry, shipbuilding, for example? That's one thing that I've got in my head as somewhere we need to go. And be creative. Don't think that kitted parts is boring in the sense that it's just you just design a panel and then you put it together like a Meccano set or a Lego model. There's all sorts of challenges which require creativity. It's a different kind of creativity sometimes. We're not making bespoke buildings, tailor-made suits, that kind of thing. But there's a lot of creativity required still. So that plays to us. So this is the digital rehearsal that we did for the kitted parts for Manchester node, Manchester Airport nodes, panelised construction, precast concrete lift shafts, and it gets put together in sequence. And I'm just going to flick on. So what happens at the end is ultimately the staircase gets dropped in through the roof and the roof gets put on. In the event, we worked through that and decided on a different approach because of the temporary works associated with that sequence that we saw, and we redesigned the staircase to provide to act as a temporary stability mechanism, so we could effectively avoid the need for big raking struts all around the perimeter of the building during construction, which in an airport and a constrained site was going to be quite problematic. Talking about health and safety, again, Dale's mentioned the health and safety benefits, so I'm going to flick over that. I'm just going to talk about additional considerations that engineers need to bring to this. Transportation and logistics, you do have to think about about how you're going to get your big components to site, so that's something you might not be used to doing. Temporary stability of structures in their partly assembled state, destabilising actions, crushing and trapping, injuries and incidents with large components if you're not handling them correctly, so you need that, and all sorts of other. Sorry, I'm rushing through this now, but we'll come back to it in the Q&A. So logistics, these are the kind of considerations that are required for logistics: types of crane, the way you transport, size of the transport. Get to know the general restrictions for abnormal loads. And then just finally, Dale said at the start of the presentation, we will come back to nuts and bolts at the end. And literally, he wasn't joking, because this is the last slide and we are looking at nuts and bolts. And this is the base plate detail for the node building at Manchester, which we refined through the design process. And I think it's just, you can see there's potential to get where that risk of trapping and crushing comes from, but also the response to that is to create this arrangement where you've got a nice sort of stable landing plate to drop the panels onto and bolt them up so that you're stable from day one. But just to be aware that there are human beings involved in this process at the end on the site, and that has to be thought about. And that was one of the points that I didn't cover in the health and safety, was ergonomics, and really thinking about the detail of how the connection is bolted up, how you can get your hand in to tighten a bolt. These are things that, until I got involved in kit of parts construction, I'd only touched on very briefly in design. In kit of parts, it's a big part of what you need to think about. So thank you very much.